Next, I will introduce the coding blocks. The first one, motion blocks. Motion is mainly responsible for controlling the movement of the robot and the movement of the task motor during the computation. The 4 available positions in the drop-down list can let the robot move forward, backward, turn right, and turn left. However, this command will continue to run indefinitely. If we want the robot to run with a specific time, we need to use the next command. Motion in set duration. This program represents a robot running at 40% speed for 2 seconds. The stop motor block can stop the robot from moving, but this block can only stop motor A and motor B. The next block is the motor power. This module can control any one of the A, B, C, or D motors to move independently. The upgrade version of this program is the single motor motion control, which allows users to add motion time so that the specific motor runs within a specific time. These 2 programs are mainly used in the task completion part of the computation, such as controlling the robot's mechanical arm and the gear movement. We can pass the video, connect a motor to controller A interface, download and run the program to try it out. The single motor rotation angle block has the same function as this block, but uses a different method. It uses rotation angle instead of time. As mentioned earlier, the first 2 motion blocks can only rotate motors A and B. But dual motor motion control and dual motor rotation angle allows any 2 motors to move. Choosing between time or angle according to actual needs. Reverse motor. Reverse the spinning direction of a motor, usually put before a motor block. The example like this. Stop motor stops the motor on a specific port. The remaining functions control the servo motor, but since this case does not use a servo motor, we will not discuss them for now. The second part is the sound and light blocks. Sound and light blocks specify the settings of buzzers, emotion screens, LEDs, displays, data, debugging, and diagrams. Mainly used in our actuator. Here are a few examples. Screen display block displays data on the controller screen with a maximum of 21 characters per line. Or we can combine with some sensors. such as ultrasonic sensors and the temperature sensor. The cross-banding detect values will display on the controller screen. Play sound. Play specific sound through the speaker of the controller. Show emoji. Show preset emoji on two dot matrix screens that are connected to two specific ports. RGB color setting. Select a preset color for LED light and the designated port. The third part is the sensor blocks. The sensor blocks help gather environmental data, including the touch data, infrared data, grayscale data, ultrasonic data, ambient light data, volume data, and magnetic data. We found that sensor blocks come in two shapes: hexagonal and rounded. Hexagonal represents Boolean value, true or false, such as touch sensor, which only have two states, pressed or not pressed. Rounded represents data types, such as number or text. In our block, we mainly use number. For example, the distance detected by an ultrasonic sensor is a fixed number. Like the ultrasonic sensor detect the obstacle distance is 5 cm. All types of sensors follow these two programming principles, and we can select the sensor module based on actual needs. They are typically used in combination with loop and logic blocks. Next part is the loop and the logic blocks. After the controller reads the sensor value, it usually needs to store the value for later use or make immediate judgments based on the sensor value for the later use. The WhalesBot Scratch Pro software provides the following code blocks. Repeat forever. Repeat forever, equivalent to the while loop in C programming, which indicates continuous execution of the content statements indefinitely. For example, we added a program to turn on motor A by pressing touch switch A. However, this program can only run once. If we want motor A to rotate every time the switch is pressed, we need to add a loop command, like this. If we want to limit the number of repetitions, you can use the repeat specific times command to archive this. Repeat N2 means that when the condition is met, the program will exit the current loop. This program indicates the motor A will continue to rotate until task switch is pressed, at which point it will stop rotating. Brakes works similarly to repeat until. It also allows the program to exit the current loop, and is typically used in conjunction with a logic block. The results of running these two programs are the same. That's the for specific second, specifies the duration in seconds during which the previous code block take effect. Less than until, equivalent to the while condition loop in C programming. If not, the previous coding block is executed. Let's for an example. This code indicates that motor A will only rotate when the task switch is pressed. The uses of logic block and the loop block is similar, and there are also uses examples in the above examples. The most classic ones are the logic statements and, or, not. We can use them according to our needs. Mathematical blocks. This is an advanced module that is not commonly used, so we will not go into too much details. You can design functions according to your own needs. Variable blocks. A variable is named location that store a value. A variable usually has specific characters. For example, we can take a name. Set variable value. Store a parameter value. A parameter return by sensor into a value. If we set value as 5, increase the value of a variable by a specific number. So the variable A is number 5, and from 1 to increase to 5. It's like 1, 2, 3, 4 to 5. And if we set it like negative number, it means the A value is decrease. And this is a variable uses function. AI-related blocks. The AI-related code blocks are designed for image sensor and AI vision module. The AI vision module supports the following features: real-time facial recognition, facial data storage and facial recognition, line recognition and line recognition, self-training for classification and recognition, and preset card recognition. However, this sensor needs to purchase separately. For example, when the image recognition sensor recognizes a dog, the controller emits a dog bark. Next is the patrol line module. Line following code blocks are designed for computations involving line following tasks. The code blocks use the PID algorithm to let robots follow lines, identify intersections, and make turns. To use the coding blocks, click the petrol light category in the left side pane, and drag and drop the code blocks you want to use. This chapter describes how to follow lines through single grayscale sensor. The operations on line following through 5-in-1 grayscale sensor and line following through magnet wheels are similar. Before explaining further, please follow the instructions in MC902 user guide to build a line following robot. The first one, initialization. This code block is used to specify the motors and the grayscale sensor used for line following. When doing line following, you must put the initialize or initialization code block right under the main code block and above all other code blocks. By default, the left motor is connected to motor port A, and the right motor is connected to motor port B. The parameters after the motor port numbers specify the percentage of power for the corresponding motors. The robot's actual running speed is the line following speed multiplied by the percentage. You can modify this percentage based on your requirements. If the absolute power percentage value for motor A and B are the same, the robot goes straight line. If a percentage value for a motor is set to negative, the robot turns to the corresponding side. For example, if you set the power percentage of the left motor to negative, the robots turn left. We have the turning functions, so normally we do not need to change the initialization value before the petrol light. Single grayscale sensors, they are connected from left to right to I/O number ports 1 to 5. Black and white detection. This process helps the robot recognize black lines and the light-colored areas on the competition fields. The black and white detection block must be used together with the initialization block and downloaded as a complete program to the controller. Now I will show you how to use our robot car to do the black and white detection. Before starting the line following, we need to perform black and white detection. Prepare the line following car we have built. Download the black and white detection program to the controller and then run the program. Note, when detecting black lines, place the grayscale sensor in the lightest area of the dark region, and when detecting the light-colored areas, place it in the darkest area. When the controller probes black line, all grayscale sensors are put above a black line.
Press the Enter button. The black line detection will be completed within 1 second.
When the controller probes white ground, all grayscale sensors are in light-colored areas.
Press the Enter button. The white line detection will be completed within 1 second.
After the detection, the controller screen displays the grayscale values. If the black line values exceed 200 and the values for light-colored areas fall below 400, you can go on with subsequent operations. If these values are outside the specified ranges, you must re-perform the black and white detection. If the value or lighting condition change, you must re-perform the black and white detection. The robot will propagate to perform black and white detection if you do not do this detection before line following. When continue the patrol line, you need to delete the black and white detection block. Otherwise, the program will not execute the next step. Pass through intersections. This block helps the robot pass through a specific type of the intersections at a set speed and continues to move forward for a set duration. The available intersections included left, right, T or cross intersection. When using this on the map, select the appropriate intersection based on the route shown on the map. The actual speed is determined by the line following speed, multiplied by the power percentage set in the initialization block. So that means it's the 30% speed for the robot car. The duration for moving forward after passing the intersection specified by the rush through intersection time parameter significantly impacts the robot position relative to black line after it makes a turn. Line following duration terminates line following after a set duration at a specific speed. This code block is added for scenarios where the robot must follow lines and then stop at a location without intersections due to the factors such as the robot relative position and the angle to the line, as well as friction. Precise control over the stopping point is not guaranteed. Turning initiates a rotation at a set speed in a specific direction and stops the rotation when the select grayscale sensor detects the black line. This block is designed to alert the robot's current heading. The three available positions is the drop-down list, corresponding to three grayscale sensors located at the center of the robot front. The selection of specific sensor will cause the robot to stop when the corresponding sensor detects the black line during the turn. The left represents left 2 channel of the grayscale sensor. Middle represents middle 1 channel of the grayscale sensor. Right represents right 2 channel of the grayscale sensor. If the power of one motor is set to negative, the robot will rotate towards that side. For example, if the left side motor, the speed is negative and the right speed is positive, and then the robot car will turn left. Since our RAS map route is relatively regular, we only select middle when we're using the turn function. Start motors. Start motors configure motors to adjust the robot movement based on time or angle, distance, sensor, feedback. This code block frequently used for robot navigation in areas where no guiding lines are found. Time control. The robot wheels move a specific speed for a set duration. Angle control. The robot wheels move at a specific angle for a set duration. Start button. When the program control reaches this code block, it enters a loop that continues until the enter key on the controller is passed. Upon pressing, the program exits the loop and proceeds with subsequent operations. The code block is commonly used after the initialization code block. This allows a delay before the robot begins operation, providing user with an opportunity to make necessary adjustment, especially in robotics competitions. Like following, the robot follows a line at a set speed. This code block must be put after initialization code block. It cannot be used alone, and it usually used together with the code blocks in the loop or logic category. Normally, we use the upgrade one, the partial duration, to replace this function. Today's demonstration route is very simple, an L-shaped route. Our task is to have the robot reach the task point and then turn around and return to the base. When the car is at starting point, the grayscale sensor cannot detect the black line, so we need to add a motion module to help the robot locate the black line. Before partialize, we must add initialize function. Next is a straight line followed by a right-hand intersection. We can use the partial line intersections right. To have the robot reach the intersections at speed of 30 and wait for further instruction. However, we will find that if we only use this command, the robot's grayscale sensor will stop at the intersection, which will cause the grayscale sensor to fail to detect the black line when turning later. Therefore, we added the rush through intersection time command to make the wheels stop at the intersection. After testing, we found that 0.1 seconds is sufficient to rush through the intersection. Next, we need to turn right at the intersection, which requires turning module. Since it's a right turn, we set the value of the right motor to minus 30. Next, we can use the partial duration command to reach the task point. After debugging, the car can reach the task point by running at the speed for 30 for 0.35 seconds. Next, we need to make the car turn around, for which we use the start motor by angle function. After debugging, turning the wheels left by 500 degrees at a speed of 20 allows the car to complete the turn. Repeat the previous instructions to turn left at the intersections to return the base. All parameters are for reference only. Do not copy them directly. Test and adjust them according to the actual situation. Let's take a look at the demonstration effect. Customize the block. In a program, some of the code blocks may be exactly the same, or the main program may be too long. In this case, in order to simplify the program, you can customize a subprogram to contain and simplify the duplicate or long code blocks. The name of the subprogram, put this block to where the duplicate or long code blocks initially are, in order to replace these code blocks. Define the subprogram, put this code block aside from the main program, and then put the duplicate or long code blocks you want to replace under this code block. Next time, if you would like to run this program, just use a single block is okay.